Hi! Welcome to this video on trig relations, or trig angle relations, or trig identities, whatever you want to call it. The assignment is to simplify these things in the top right corner, these signs, and see what they become. In order to do that easily, we need to distinguish between two groups, the groups of rotations and the group of reflections. Of those four things, of those four signs, only the sign of 90 minus x is a reflection. How do I know that? Because rotations are always of the form x plus or minus some angle, 90 in this case, and sine 90 minus x isn't that, it's the reverse. You might say, what about sine 90 plus x? That is also the reverse. It looks more like this, and you'd be right. However, sine 90 plus x equals sine x plus 90, because addition is associative. 2 plus 3 is the same as 3 plus 2. That is not the same when you subtract, so with the minus sign it's not valid. 2 minus 3 is not 3 minus 2. So we might as well just treat 90 plus x as if it's a rotation, because it is the same as x plus 90. You get the same result. So we can kill two birds with one stone. So first we'll look at reflection, because there's only one in this setup. A reflection around what? Well, a reflection in the first quadrant, because it's about 90 degrees, so it's only in one quadrant. And it's a reflection over the center of the quadrant. So now you can already see sine's reflection. Sine's reflection is cosine. So the sine of 90 minus x equals the cosine of x. This is the reason why cosine is called cosine. It stands for complementary sine. Complementary sine. And this 90 minus x thing, that is what we call the complement. So we need to recognize that. That is something that we need to know when we see that form, 90 minus x or alpha or theta, doesn't matter. That is a complement. So cosine of 90 minus alpha is also a complement, and the reflection of cosine is sine. And tangent 90 minus theta, that is also a complement, and then we have the cotangent of theta in this case. Also cotangent, complementary tangent, that is why it is called like that. So these things with 90 minus an angle are always complements, are always reflections, and we can very easily find those either by drawing them on the circle and just looking. We can now see that cosine is the mirror image of sine, or by just knowing a little bit about the names. So for the other group, rotations, which are always of this form, x plus or minus an angle, 90 degrees in this case, and we're going to look at sine x plus 90, which is the same as looking at sine of 90 plus x, give the same answer. And this plus 90 here means a 90-degree rotation counterclockwise, because of the plus sign. Plus sign is counterclockwise. Now what is going to rotate? What is going to rotate is the axis. So the y-axis is going to rotate 90 degrees, and the x-axis is going to rotate 90 degrees. Now if you imagine that this cosine here in my original drawing is attached to that red x-axis, then that cosine is now here. And if you imagine that this sine is attached to the blue y-axis, then this sine is now here. So for the original point, the original point, we had described it with a cosine and a sine. Those are the coordinates of the point. And we can now see that they have become negative sine, cosine. Why? Because this cosine here, which represents the x-axis, now holds here this blue sign, and also it's on the negative side, so it has a negative sign. And this sign over here, which represents the y-axis, now holds this red cosine. So we see that when we rotate 90 degrees counterclockwise, that cosine goes to negative sine and sine goes to cosine. So in this case, sine x plus 90 is cosine of x, and sine 90 plus x is also cosine of x because of the associative property of addition. So that is that. And then we just need to look at what happens to the last one, sine of x minus 90. So it's also a rotation of the axes themselves, but clockwise this time because of the negative sign. Negative sign means clockwise. So this blue y-axis is going to rotate negative 90 degrees, which means clockwise. And this red x-axis is also going to do that, so it's like that. So what will have happened to my cosine here that is attached to this red thing? It is now here. And what will happen to my sine that is attached to this blue y-axis? It is now here. So again, if we have the original point expressed in terms of cosine and sine, we now see that on the x-axis we have a sine. And on the y-axis we now have a cosine, but it also has a negative sign, so it's negative cosine. And so the sine of x minus 90 degrees is negative cosine x. And this works for all trig things like sine and cosine and tangent and whatnot. Actually, if you just know sine and cosine, you can always just stack them on top of each other and you can see what the tangent becomes. So you don't even need to really know how tangent evolves. If you know how sine and cosine evolve, then you can just stack them and create the tangent, or the cotangent if you stack cosine on top of sine. So this was my video. I hope you learned something, and thank you very much.